Hi guys, welcome back to my channel. For those of you who are new, my name is Jag, and this channel again is all about high school math, science. We cover grade 11 and 12 chemistry and biology. So with that, let's get started. Alright, today's class is going to be on chemistry 11, and what we're covering is balancing equations. So this was a topic that was covered last year as well. So we're going to kind of go through a refresher for grade 11 chemistry. Alright, let's take a look at this example that I have on the board. Alright, I have sodium plus chlorine, and there's this arrow, and the arrow actually means yields, or it produces sodium chloride. Okay, in one of the last videos, we did go through how to name the compounds. You have to make sure you're adding IDE at the end of this nonmetal because sodium chloride is an ionic compound. Okay? We're going to try actually balancing this equation. Alright, so we're going to draw out this table. On the left side of the table, I want everyone to write down reactants. Okay, on the right side of the table, we're going to write down products. Okay, so if balancing equations is something that you find that you have trouble with, what I would do is always draw out this table because you can't go wrong. I can see exactly how many atoms of each element I have. Okay, so what we're going to do here is I'm going to write down each of the elements separately. So I'm going to put Na, sodium here. And also we're going to put chlorine separately as well. Okay. The same thing on the product side. I'm going to put sodium and chlorine. Okay, if you actually have more than one of these elements, I would make sure that I'm just lining them up. And there's a reason for that. It's so I can actually see and make sure I have the same number of atoms of each of the elements on both sides of the arrow. Okay, if I'm looking at the reactant side here, I can see there are no numbers for sodium. So the sodium atom is going to be 1, okay? If I look at the chlorine, remember that chlorine is a diatomic molecule, which means I can't just write Cl when it's by itself. Diatomic means I have 2 atoms of chlorine, okay? And they are basically attached to each other like this, and that's how stable chlorine would be within the environment. This is how it's actually found. So here I have 2 atoms of chlorine. Okay, so again, we're just counting the number of atoms. Let's go to the product side. And I see for sodium, again, there are no numbers here. There's 1 sodium. And the same thing with chlorine. I have 1 chlorine atom on the product side. So now, if you look at this table, I can see that it's really easy to see what is not balanced here. Okay, so in this case, the sodium is balanced. I have 1 atom on both sides. Okay. However, for chlorine, I have 2 atoms of chlorine on the reactant side, and there's only 1 atom of chlorine on the product side, okay? So I'm going to put a number. So whenever you put these numbers as coefficients, they have to be put in front, okay, of the element or the compound. I have 2 chlorines, okay, on the reactant side. On the product side, I'm going to put a 2. I'm putting a 2 in front of the NaCl, okay? And when you do that, I have to make sure I change everything. So if you look at sodium now, I have 2 atoms of sodium. So I'm just going to cross it out and put down 2 here, okay? And then for chlorine as well, I have 2 atoms of chlorine. So I'm just going to cross that out. All right, and I'm putting a 2 right beside it. Okay, and does everyone see that? Every time you put a number in front as a coefficient, it applies to basically all the elements within that compound. So I have to make sure I'm changing all the numbers here. Okay, so one more time, we're taking a look at the table. All right. I see the chlorine is now balanced, but take a look at the sodium here. Okay, for the product side, I have 2 atoms of sodium. And for the reactant side, there's only 1 atom, okay, of sodium. I have to make sure I'm balancing the sodium on the reactant side. So I'm going to put a 2 like that in front of the sodium, all right? And now there are 2 atoms of sodium. Okay, just like that. And now if I'm looking at the table, there are 2 atoms of sodium on both sides, and there are 2 atoms of chlorine on both sides as well. Okay? This is the balanced equation. It is 2 sodium plus chlorine. It is yielding 2 molecules of sodium chloride. Are there any questions there? Okay, so that looks good. What we're going to do is go into the textbook. We're going to try one more example. Okay, so this was just a simple one to make sure everyone remembers how to do it. Okay, so I'm going to take this off. And we're going to try an example, okay, which contains like the polyatomic ions as well. And I want to show you just a quick method of doing these compounds. We're still going to draw out the table. Okay, so let's write down the example here. So this is CuNO3 2. Okay, and what I'm adding is KOH. And it's going to yield, and I'm going to write it kind of small here so we can see it. Alright, so it's CuOH2, alright, plus KNO3. So there are several topics, okay, in grade 11 chemistry, which is you might find as a review from grade 10 science, okay, the chemistry section. And that's all right as well. It's going to be one whole unit. That's almost like a review, which is on the types of reactions, okay? So what we're going to do here is I'm just going to draw the table like this, okay, so we can see it. We're going to write reactants on one side, okay? And the same thing as before, we'll put products, okay, on the opposite side. Okay, so what I wanted to show you is when you have a polyatomic ion, which is something like this, NO3. Okay, polyatomic just means you have 2 or more different elements and they're combining together to form the compound. I'm going to write them actually together, okay? So even for the OH, if you can see that, I'm just going to put brackets around it just to keep it separate. So what we're going to do is the Cu, okay? We're going to do NO3 like that, okay? Then I'm going to write it on this side so we can see it. So potassium is K, and then the OH is the hydroxide. So just like that. And we're going to write the same thing on the product side, okay? Before we start counting the atoms. So I'm going to put K and OH, okay? So we have to make sure we're looking at each of these atoms and molecules very specifically. So for Cu, there are no numbers here. There is 1 copper. Alright, so here I'm not breaking down the nitrogen and oxygen. I'm just writing NO3 here, okay? If you see there's a number 2 outside the brackets for NO3, which means I have 2 molecules of NO3, okay? And I'm going to potassium. I don't see any numbers here. There's 1 potassium and there's 1 hydroxide ion, okay? Well, in this case, it's not an ion. It's actually part of the actual compound. We're going to go to the product side. Again, there's nothing for Cu here, which is on 0. There's 1 atom, okay, for copper. And for OH, again, I see that there's 2, okay? So we're going to put 2 for OH. Make sure you're looking at where you're putting the numbers as well, okay? That's important. There is 1 potassium. There are no numbers for NO3 as well. So there's 1 NO3 molecule. So just like that, okay? Again, whenever I'm adding the numbers as a coefficient, it can only be in front of the compound or element. I can't start writing the numbers at the back over here somewhere, okay? Because that is wrong. Okay, so if I'm taking a look at my table, okay, I can first see that the NO3 is not balanced here. On the product side, there's only 1 NO3, okay? So the only way I can change that is by putting a 2 in front here. So I'm putting a 2 in front of the KNO3, okay? Which changes the potassium. The K is also going to be 2, all right? NO3 is also going to be 2. So what I recommend is you just like crossing it out and putting the number right beside it so you can see it. Okay, so I'm going to take out this line here so we don't get confused, okay? So I can see the NO3 is now balanced, okay? Let's take a look at the OH. I have only 1 OH on the reactant side here. There are 2 OHs on the product side. Remember, OH is just a hydroxide ion, and which indicates the compound is a base, okay? So on this side, I'm going to add 2 on the reactant side for the KOH. So again, the potassium becomes 2 here, all right? and then the OH also becomes 2. Again, whenever you put the number in front of a compound, it's going to change each of these elements. Okay, I have to make sure I apply it to everything. So now we're taking a look at our table one final time. There is right here 1 copper atom on both sides. Okay, there are 2 atoms of potassium. There are 2 atoms for nitrate, which is NO3. Okay, and I see 2 atoms for the OH, which is the hydroxide ion. All right, this is my balanced equation. So there's only a 2 in front of the KOH. Okay, there's a 2 in front of the KNO3, which is potassium nitrate. So that's the balanced equation here. If there's nothing there, there's actually just a 1 in front of these compounds. Okay, I don't need to write the 1 again, just like in math. We don't need to keep writing 1 wherever you don't see it. It should only be if the number is greater than 1. Okay, so that brings basically this video to an end. Thank you for watching. And if you liked what you saw here and you learned about balancing equations, please click on the like button below. Make sure you are subscribing to the channel, and I will see everyone next time. Bye!